today's class, we are going to start with the topic relations. To read the relations, I have split into three categories. First, we'll see what is the relationship, and the second category we'll see how to relate it using the symbol R, and the third category we are going to represent it in an ordered pair. First example, what you are going to see is New Delhi is the capital of India. So New Delhi is connected to India because since New Delhi is the capital of India, while expressing it in using the symbol R, we can write it as New Delhi is related to India. So this is how we represent it using the relation R. The same thing we are going to write it in an ordered pair, whereas in an ordered pair we will write it as New Delhi, India. So the relationship itself we have denoted in three categories. We will see another example, whereas -1 is greater than -5. So we know -1 is greater than -5. -1 is related to -5. So which we are representing using the symbol R. Next, while representing it in an ordered pair, we will represent it as -1, -5. So this is how we will represent a relation. So -1 is greater than -5. -1 in a symbol we represent it as -1 or -5, and in an ordered pair we represent it as -1, -5. So in an illustration we will see how we relate it in an arrow diagram. In an illustration 4, students in a class and heights of the students in a class are given. We have to express this relation in an arrow diagram. Before expressing it in an arrow diagram, we will write it in an ordered pair. Then accordingly we will map it in an arrow diagram. So in a relation, we are going to represent it in an ordered pair like heights, students. So first we will write the height, then the students representation. So R is equals to 4.5, S1, which means student 1 is in the height 4.5. We will go in an order. As well, student 4 is in the height 4.5. So we will write that 4.5, S4. And the next one is student 9 is in the height 4.7. That can be represented as 4.7, S9. Next, student 10 is in the height 4.9. That can be written as 4.9, S10. Next is in an order we will get 5. So student 3 is in the height 5. So 5, S3. Next 5, S5. 5, S8. So 5 is over. Next we will move on to 5.1. 5.1, S6, because student 6 is in the height 5.1. After completing 5.1, we will go on to 5.2. So student 2 is in the height 5.2 and student 7 is in the height 5.2. So we have represented the relation in an ordered pair. Next we are going to represent the same relation in an arrow diagram. So while representing it in an arrow diagram, this represents the heights and students. So heights it is given as 4.5. Since it is repetitive, it is enough to write only one time. 4.5, 4.7, 4.9, 5, 5.1, 5.2. And in the next one, S1, S2, S3, S4, S5, S6, S7, S8, S9, S10. So what we have to do is we have to mark accordingly. Student 1 is in the height 4.5. So 4.5 has to map to S1. Next student 4 is in the height 4.5. So 4.5 to S4. Next student 9 is in the height 4.7. Therefore 4.7 to S9. Next 4.9 goes to S10. Next 5 to S3. 5 to S5, 5 to S8, 5.1 to S6, 5.2 to S2 and 5.2 to S7. So this is how we will represent the relation in an arrow diagram. Now we will see the definition of an relation. So we will consider two non-empty sets A and B. Let A, B are two non-empty sets. R is a relation from A to B. Which is represented as subset of A cross B. Subset of A cross B means we know what is A cross B. We studied in the last class. A cross B represents the set of all ordered pairs. So relation from A to B means which will be the subset of A cross B. If X belongs to A is related to Y belongs to B through R, we can write it as X is related to Y. Whereas X is from A and Y is from B, we know what is A cross B. It is a set of all ordered pairs. So this X related to Y is only applicable if and only if X comma Y is an ordered pair in a relation. So X is related to R is applicable only if and only if the set of all ordered pair X comma Y is related to R. Next we are going to see example 1.4. In an example 1.4 we are given with two sets A and B. What we have to do is we have to find whether the following sets are related from A to B. One thing we have to note down is whether it is related from A to B. So we must write the cross product of A cross B. Why are we writing the cross product of A cross B is by the definition of a relation can be checked by whether R is a subset of A cross B. So first we will write the cross product of A cross B. Then we will check whether these three following sets are related from A to B. So first we will write the cross product of A into B. What is the set A? 3, 4, 7, 8. Cross product it with B. 1, 7, 10. So A cross B will be 3, 1, 3, 7, 3, 10. 4, 1, 4, 7, 4, 10. And the next one is 7, 1, 7, 7, 7, 10. Next is 8, 1, 8, 7, 8, 10. So this is the cross product of A into B. So first we will check it for the first subdivision. 3, 7. Yes, it is present in A cross B. Next 4, 7. It is present in A cross B. Next 7, 10 which is present in A cross B. 8, 1 which is present in A cross B. So R1 is the subset of A cross B. Therefore R1 is related from A to B. So R1 as a relation from A to B. Similarly, by the similar steps we have to check whether R2 is a relation from A to B and R3 is a relation from A to B. So for that we have to see whether R2 is a subset of A cross B. Yes, 3, 1 is present in A cross B, whereas 4, 12 is not a subset of A cross B. 4, 12 doesn't belongs to A cross B. So R2 is not related from A to B. Since 4, 12 doesn't belongs to A cross B, this R2 is not a relation from A to B. Next we have to check whether R3 is related from A to B. For that also we have to follow the similar step. We have to check whether R3 is a subset of A cross B. We'll do that. First 3, 7 is present in A cross B. Next 4, 10 is present in A cross B. 7, 7 is also present in A cross B. 7, 8 which is not present in A cross B. So here itself we can conclude that R3 is not related from A to B. Why? Because 7, 8 is not in A cross B. Therefore, R3 is not related from A to B. So in these three given relations, only R1 is related from A to B. Other two, R2 and R3 are not related from A to B. Next is example 1.5. What it is given in the problem is the arrow diagram shows the relationship between the sets P and Q. We have to write the relation in set builder form, roster form. Also we have to write the domain and range of this relationship. Okay, so in this relationship, this represents the set P and this represents the set Q. 5 is mapped to 3, 6 is mapped to 4 and 7 is mapped to 5. So first we will write it in the set builder form. How to write a set builder form? Set builder form can be written in a notation. The notation must satisfy all the function that has happened in the sets P and Q. So what will we do is, we will write it as x comma y, that is an ordered pair such that y is equals to x minus 2. X is from P and y is from capital Q. Why I have chosen y is equals to x minus 2 is, this notation will satisfy all the functions. For example, P represents this values as x and this represents the values as y. So first I will take 5, 3. As I told you, this is x, y. So we have taken the notation as y is equals to x minus 2. What is the value of y for this pair? 3 and x minus 2 means it is 5 minus 2. So 5 minus 2 will give us 3. X, y. So this notation is satisfied for 5, 3. Similarly, we will check this notation for the other two pairs also. We will check it for 6, 4. We will check for 6, 4. Where it is 6, 4, this is the value of x and this is the value of y. The same notation we will check whether it is applicable for 6, 4. So 4 is the value of y. X minus 2 means 6 minus 2. 6 minus 2 is 4. So this notation satisfies for the pair 6, 4 also. Therefore, we have constructed the pair in a correct format. Similarly, we will check for 7, 5. So for 7, 5, this is the value of x and this is the value of y. Y is equals to x minus 2. So y value is 5 and x value is 7. 7 minus 2 will give us 5. So this notation satisfies for all the three functions. So we have to build a set builder form in a way that it satisfies all the functions that has given in this sets. So first in a set builder form we have written it as ordered pair x, y. Y is equals to x minus 2, whereas x is from the set P and y is from the set Q. So we have completed with the set builder form. Next what we have to do is we have to write it in the roster form. So roster form is nothing but writing it in the set of all ordered pairs. How to do that? We know to write set of all ordered pairs. In a set of all ordered pairs, we will write it as x, y. X, y means, as I told you, the elements in the P is called as x and elements in the Q is called as y. So while pairing it, we will write it as 5 is mapped to 3. We can write it as 5, 3. Next 6 is mapped to 4. We can write it as 6, 4. Next 7 is mapped to 5. We can write it as 7, 5. So we have written in set builder form and in roster form. And the third thing what we have to write is, we have to write the domain and range of R. Now comes what is a domain. Okay, so domain is nothing but the elements present in the set P which has a mapping. Not all the elements which is present in the set P. For example, 5 has a mapping, 6 has a mapping and 7 has a mapping. So domain is 5, 6 and 7, where we will not include 8 because 8 doesn't have a mapping in the other set. So domain is nothing but the elements in the set P which has a mapping with the other set. So domain can be written as domain of R is 5, 6, 7. Okay, next we have to write range of R. What is the range of R is nothing but the elements in the second set which has a mapping. So all the elements in the second set, that is 3 has a mapping, 4 has a mapping and 5 has a mapping. All the elements in the set Q has a mapping. So the range is 3, 4, 5. So this is how we have to write domain and range of any problem.